We'll see how I do. So we're on the back of 13. What's volume measure? What is volume? We use that word. What the heck am I measuring? I'm measuring volume. I use stuff like this to measure volume. What do you think, David? David says. How much room it had. Okay, room it takes up. I got you. How much room it takes up. If I said the volume of this trash can, excuse me, how much room it takes up. Find something. Not a choice thing. Yeah. Volume of this book. How much room it takes up. So you could put room it takes up. Obviously my space. Having a space. What? Anybody else got a different way of putting that? Thank you, David. Volume measures the amount of. I just said it accidentally. Space. That's the same. Not the same, David, as room. Space. That can fit there. Space. Something's taken up. Obviously, the volume of this filing cabinet is more than the volume of that trash can. The volume of these closets is more than the volume of the file cabinet. Okay, space or room something takes up. Great. We always got base units. Base unit for distance is meter with an M. Base unit for mass was gram with a G. What's left here, folks? What's left? What might we measure volume? Page says maybe in.
Wait, what?
Maybe the base unit. Kyle says maybe it's the liter with an L. Thank you. Get out. Whoa, that was strange. Let's try this again. I suppose you should abbreviate that. Yeah, what I say often, this L we do to that we normally don't do to when we abbreviate. Yeah. Quite often we then capitalize it just so it doesn't look like a 1 or something. Now, you got a feeling what a meter is, you got a feeling a paper clip's like a gram. Here's a liter. That's a liter. That's 2 liters. All right, that's the most common. If I said liters, the first thing that pops into my mind is this 2-liter jug. So chop that in half, you got a liter. Anything in this room that's about a liter in volume, would you say?
That'd be great, but I'm not going to be here until Friday. All right. So,
Looking around. It's about a liter. No, it's about a liter. What? Or more. You got a 2-liter object somewhere? Don't say that bottle. About a liter. I'm thinking the speaker takes up about a liter worth of space. I'm thinking this soap container's taking up a little less than a liter's worth of space. Anybody else got something? What you got there, Brian?
Turtle shell.
My turtle shell. If somehow I could change the shape of it. If I fill this full of water and pour it in there, this amount of water might fill that space. I like that idea, Brian. Anybody? What about this globe? This a liter?
Nope.
About how many, won't you say?
3, 4.
3 or 4? You're probably right. Maybe 5. Not too many leader-looking things in the room. Right? What about a pencil sharpener? More or less than a liter. How much of a liter, maybe? Maybe half a liter?
Oh.
Maybe half a liter? Okay. I got a feeling for it.
I
What?
was going to say the soap dispenser.
This soap dispenser, more or less. Okay, that object, but I bet the package of soap inside is probably close to it, right? Right, gotcha. Okay. Now, most of the times, we're measuring stuff smaller than whole liters. And most of the times you use liters to measure liquids. We're measuring chemicals in here, we're measuring liquids. All right? So we're using little pieces. So most everything we talk about will be in milliliters. (150 milliliters of hydrochloric gas, 220 milliliters of peroxide. Okay, I see a prefix and I see a root word. So I'm looking for 2 letters to abbreviate. And I like the capital L. You could make a lowercase l. It just makes it not look like a 1 to me. What are they? I'm hearing 2 things. Right. Good. Let's be careful on the microphone. Because you're being recorded. Thank you. What's the difference? There's some things back there behind Mrs. Fagan. They're kind of short and fat. I didn't say it was Mrs. Fagan. And over here by Kyle, they're kind of tall and skinny. We need to know the difference. These are graduated cylinders. Cylinders, tube-like. They're shorter and fatter than their beakers. All right, we're going to use these today, and you're going to just practice a little bit, so we use them for real. We're good at it. So my concern is that I'm going to use the term increments. Mr. Bryant calls them gaps, he says. So if this is your graduate cylinder, the one on the left, and I said front row, how much is each little line worth? Or as I go up each gap,
10.
they're going up by tens. So that's 10, 20, 30, 40, 50, 60, 70. It just works, doesn't it? Okay. So sometimes you just kind of look at it and it jumps out at you. Not so bad. Second row. What are the increments? What are the gaps? What's each line worth? Thank you, Julia. See, that's a 1, that's a 2, 3, 4, 5. Boom. This jumps out at you, doesn't it? Third row. Third graduated cylinder. Doesn't jump out at you, does it? Darn. What? It's going to be something in that neighborhood, isn't it? Because he said, let's try it. Well, let's say that's 15. What's the next one? 30. The next one would be 45. And the next one would be?
55.
I like that. Uh-oh. Anybody else have an idea? Or a way of figuring it out? Anybody else in the third row? Jay says.
Take 50 and divide by 4. 4.
Why did you divide by 4?
Because there's 4 increments. 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 4 increments.
Beautiful. He says in 1, 2, 3, 4 increments, 4 gaps, 4 steps, I got to get to 50. So Jay says, remember how to divide this way?
No.
Oops, that's an 8, so I can't do it. Duh. All the years I've been doing this, Jay, you might be one of the first people to have ever, bam, said it to me that way. Okay? So each increment, Jay, must be worth how much? 12.5. So, first step must be 12.5. Second step must be, what's 12.5 and another 12.5? 25, thank you. I didn't hear you. 37 point. Wow! I'm astounded. I'm proud of you. Here's so much money. So much money. Okay, when you, sometimes they jump out at you. Sometimes they jump out at you. No math necessary, there isn't. But let's try Jay's method. We went back to this one. In 2 steps, we went up 2 milliliters. Hey, they're each worth 1, but we didn't have to do all that in our head. Let's go back to Brian's. In 2 steps, we went up 20 milliliters, so each step must be worth 10. Okay, jump ball. It's 3, they're going up by 3s. Did you use Jay's method or did it just come to you? All right. One reason it kind of jumps out at you, the first step is called 3. So I bet they're all 3s. All right. 6, 9, 12, it worked. 15, 18, it worked. If we use Jay's method, we would start at the 3, go up 1, 2, 3 increments. In 3 increments, it went up how much? Went from 3 to 12, so it went up 9. So that would work all right. Okay. Everybody got a picture or two of what you did? Should have. Because it makes them safer. All right, when you're holding them, they go up, I understand. But if you go, when you go to put them away, when you dunk them, they're gonna lay down. It's safer. Now, I gotta talk about that yellow collar at the top. See if I can get someone to say what I want them to say. What's this for?
You can measure. So like, you read your measurement.
Someone has told you you measure with it. I'm going to tell you something different. It's to keep them from breaking their little necks. It's a safety collar. That's all it is. It's not to measure with. Someone may have told you that. It's okay. Doesn't mean they're a bad person. It means they don't. I won't go there.
Can't you use it for that?
It's a safety collar. If I slide it down here to measure it and then it falls over and it breaks, all right? So, I push it above the top line and leave it there. Doesn't break, does it? Okay, we don't have to all test them, but it's supposed to keep them from breaking. That's all it's there for, honest. Honest. All right, so, thank you. Well, okay. So, on your first sheet of paper, you have this thing, and it shows a curved line. And what's the big fancy bold word that says that when you pour water in it here today, when you do pour water here in any minute now, the water's going to stick to the sides, and it's going to make this funny U shape. And the name for that is? Yeah, thank you. It's right there in your paper, isn't it? So the real question is, where should I read it? So what's it say to read there? Well, where's it say to read it? Right there in the opening instructions. Where's it? Go ahead and read it. There you go. So, ladies and gentlemen, in your picture, in my exaggerated picture, Hannah, would you say I should call it 13 or should I call it 12 according to what Will just told you? Yeah, yeah. Now, it's not going to be that big on the real deal, but you will notice it today. You will notice it. What if, well, let me get it right here. Well, if this was 12.3, and that was 12.2, and that was 12.1. Dylan, what would you call that one? Mine up here. Yeah, they're all 12s. Thank you. We're okay there? We're reading the bottom of the curve, and you will see that today. You will see that today, definitely. All right, so back to yours. We're going to do number one together, then you're all on your own. All right, you have a 100 mil graduated cylinder. Starting at the 10 line. So put your finger on the 10 line, one of you. There weren't any left? Who did I give it to? Excuse me. I didn't see there. Share with your friend now, all right? Start at the 10 line. Put your finger on the 10 line. Count the lines and stop when you hit 20. Did you count the last line? Did you count the 20 line? So she'd say 10. And what just happened there is what I figured would happen. Think of it like a race. You started at the 10, so that's 0, and you need to get to the 20. So I got to count the last line today. All right, that's exactly 10 lines. So if I go up 10 milliliters, Jay says, in 10 lines, hey, each line must be worth, well, that's a simple one, isn't it? Now what you are going to do by yourself, not with a partner, and it gets kind of messy, is you need to do 2 more graduated cylinders, the 2 smaller ones over there, and you turn to the second page, you need to do those 4 beakers behind Mrs. Fagan. You with me? And it's going to be the same kind of questions over and over and over. Starting at this line, count the lines, how many lines, what is each increment, each gap worth, those kind of over and over and over. Then, oddly enough, you're going to get 75 mils of water. You're going to bring it to me. I'm going to sign off on it. Now, I know Tessa could do this and then give it to Brianna, and then Brianna can show it to me, but did Brianna really learn from that? So I'm asking Tessa to dump the water out before the next person uses it. So what's that mean? There's going to be a lot of water in your sinks, these papers will get wet, sometimes science is messy. Questions? Okay, so the person who has the graduated cylinder now is going to go ahead and do the first page here in a moment. And the people without graduated cylinders right now are going to turn the page. All right, then we'll start on the second page with the beakers in the back. Making sense? And if you're on the back, you're going to do 6, 7, 8, and 9. Ignore the last box today. Ignore the last box today. As you beaker people get done, if there's time, you'll come back and do the graduated cylinders. As the graduated cylinder people get done today, they're going to go do the beakers. So hopefully today you'll get through all of those, and it'll become a wet, messy lab. You make a spill, clean up, etc.